Here's going to be the gist of this. No. Here we go. Let's take a quick gander here at this. First, I'm going to recalibrate because Nuzo was not tall enough to actually hit the middle of the target. That's not her fault. You got much closer than Shell now. Okay, take a quick look at this here. The first question we must answer here, and if you could sketch this little cone out on your piece of paper, that would probably do you well. And you should be able to sketch it. Just a little circle, little dunce's hat. Okay, and then this thing here is got its little dashes. Remember when we talked about height, the height of something is always perpendicular to whatever you're talking about, okay? So here is, the base of this shape is this circle, okay? The dimension of the circle, the diameter of the circle is 10. This 12, because it goes straight up at a right angle, this is the height. It is not the slant height. When they talk about slant height, it's just what it sounds like. It is the distance from the base to whatever, the vertex, but it's a slanted line, okay, which will be different than 12. 12 is a straight up line that goes straight up from the base at a right angle to the top right there. Okay, that is 12. The slant height is that one right there, okay? Now, how do you figure, or what do you suppose you're going to do to use to find that? And they give you a little hint right here because they took like what we call a cross section. In other words, they cut that cone right down the middle. And what shape do you end up with? This little shape right here, which is 10. We know that this is 12, and we're looking for this. How would you go about doing that, Lucas Espanol? Well, and you're going to look for a triple because this triangle here is, well, I missed it, sorry. This is a 512. 13. Is there a 512?
13.
12. So the slant height would have to be 13 centimeters. So that is the slant height. This is a little bit of geometry, so you got to like it. Sorry, Jeremy, if I'm boring you. I'll try to do better on this next one. Is that all right? Everybody clear on that? The Pythagorean theorem, children, comes up an awful lot. Here's another one. Maybe I'll take away the bottom here since we can't figure this out without. I don't know what happened there. What did I just do? What did I just do again? Shouldn't I just be able to do this? So here's my thing here. Armand is building a model of the Great Pyramid to approximate proportions. The base of the pyramid will be a square, 30 centimeters on each side. He wants the height of the pyramid to be 20 centimeters. What should the slant height of the triangular face sketch the net of the Great Pyramid he is building? Love that. Remember the whole net is the thing there. So you've got this 30 by 30 base. Okay, put a little point up here. This gets connected to all those sides there. It's said that the height is 20 centimeters, so you know that from the vertex there straight down, forming a square with the base, is 20 centimeters. And they want to know what will this slant height be. Okay. So they gave you this little advice here to sketch a net. Well, what would the net look like? You've got your 30 by 30 base, correct? Off of that is going to be 4 triangles on each side. Triangle, 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 triangle. What do you know? You know that all these sides are 30, right? Because it's a square base. And we know that the height of every triangle is 20. So this little dashed line is 20. this is 20, this is 20, this is 20, and they're looking for the slant height, which would be any one of these sides. Let's pick this one here. So again, it is Pythagorean theorem. The one thing you have to be careful with is, if you're looking at this triangle right here, what is its height and what is its base, or what are we using for it? It's actually going to be, here's my triangle. It's only half of this big triangle, so it is 15 here, correct? 30 here, and you want to know what that is, right? Yes, Mr. Hunt, we understand. Because you're only using this part of the triangle for your right triangle. You don't use the whole base. So what is my third side going to be? Pythagorean theorem. Is there one up there? Well, again, you got to look at, these should be reduced. What number goes into both 15 and 30? Well, 15 does actually. Divide them both by 15, you get a 1 and a 2. Is there a 1, 2, something? No, so what are you going to have to do? You're going to have to actually do it out. Is that what you're going to say, Lorna?
Wait, isn't it 20 though? Or 20 by...
Oh, did I put the wrong number? Oh, it's 20, sorry. Well, that makes more sense now. What goes into both of them? Did you say 5? Oh, it is a 3, 4. It is a 3, 4, and then the hypotenuse is 5, but it's not really 5, it's actually, right, because you divided it by 5, you have to multiply by 5. So the slant height would be 25. I apologize for me. Here, Lord. Now, do you think, Brandon Norman, you could do this without sketching all this stuff out? I'm sure you could. You could try to do it, but what's going to happen? You get who? Well, you might not get it wrong, but what's going to happen? You'll get in trouble. So right now, I want you to do this one for me. Find the slant height of that cone. The slant height of that cone. The slant height of this cone. Price.
Is the height 6 or
That height is 6. Are your contacts not in?
not?
This is 4. So the answer to that would be no, they're not, right? Do you need contacts? Is that too far? Sage, can you see the numbers from there?
Yeah.
Oh, you're right, I can't see either. Now, I apologize even for the insinuation that you could see that. I could see that. Better? So just for clarifications, on your paper then, you would sketch this out, just like it is there. 4 inches, 6 inches. And then they said sketch a right triangle. So again, that we call that the cross section. If you cut that right down the middle, you'd end up with a shape that looks like this. And you know it's 4 inches all the way across, and it's 6 inches in the middle. Please remember, you are only using half to get a right triangle. You can use the whole thing. Which means, did we get an answer there? How many Haynes?
Square root of 52.
Square root of 52. Hey, oh, Nick?
I got 5. I got 2 times the square root of 5.
2 times the square root of 5, which is the square root of 20.
Yeah.
But 2 times the square root of 5 would be our simplest form. Square root of 10. Nobody's jumping on any of those bandwagons, Colin?
I got the square root of 40.
Square root of 40, which would have to simplify though,
Oh,
be what? 2 times the square root of 10, I believe. Well, let's take a look and see. Let's just take out the triangle that we're using. The triangle we're using looks like this. This is 2. This is 6. And we want to know the hypotenuse to that. So it's a squared plus b squared equals c squared. 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. 40 equals c squared. C equals the square root of 40. And if you do the whole factor tree, whatever it is, it's the square of 4 times the square root of 10. It is 2 times the square root of 10. 2 times the square root of 10.
4 was,
What's that?
I said 4 was the height. I'm gonna lie.
Oh. Lauren?
heard that, like, I did do that, but could you reduce those? Or like,
Well, I'm gonna guess, like if you change this to a 1 and a 3, at the end you'd have to remultiply your answer by 3 at the end. Would that give you the same answer to get square root of 10? Now, you don't want to reduce unless you're looking for a triple. I think after that you wanna work it out straight. What did you reduce?
or like, I did the 2 and the 6, and I did 1 and 3.
Okay, you did 1 and 3, and then which meant you divided them both by 2, right? And what'd you get for an answer?
The square root of 10.
Right, but see, the square root of 10 then needs to be remultiplied by 2, because what you did was a proportional triangle that was half the size. So if you want to get back to the original triangle, you're gonna have to remultiply by 2 at the end to get the blow back up to its normal size. I would say you'd only want to do that reducing thing when you're looking to see if it's a triple, otherwise go back and use the actual measurements there. That would be my personal thought process on that. Does that kind of give you a gist there? How many people feel